Hi guys, I'm just going to go over a couple of the solutions. Even though they're provided for you, I just want to kind of walk you through the steps so you see where everything's coming from, as well as provide some additional explanation. So this is from 1.4, the exponent laws. You should watch all the videos on this page for an explanation of why these laws work, but I'm just going to go right into the answers. Here's the summary of all the different exponent laws: the multiplication, division, and exponent to exponent. And you'll remember the multiplication law is when you're multiplying two things with exponents, the base is the same, you leave the base alone, add the exponents. The division one is very similar, except you leave the base alone and you subtract the exponent. And exponent to an exponent, again, leave the base alone and multiply the exponent. So let's look at some of these practice problems. So this first one is pretty straightforward, application of power to a power or exponent to exponent. Where we can actually see that it's x squared to the power of 4, and the short version of the solution is you just multiply the 2 by the 4 and you write it down as a new exponent for the x. What's actually happening here behind the scenes, and I'll show you, is remember what an exponent means, right? It means multiply the thing in the base by itself this many times. So what it's actually saying is take x squared, multiply it by itself 4 times. So this is an unnecessary step just to illustrate why this property works. It's probably in those Khan Academy and Mathmodo videos as well, but that's actually what's happening there. And then for these, you just apply the addition of exponent rules for multiplication. To go even further into this, here's x to the power of 2 actually means x times x. And so does this x to the power of 2. So it's x times x as well. This one's x times x as well. And this last one is x times x as well. So you actually see when we break this all down into its tiny pieces, we actually see it's x times itself, 1, 2, 3, 4, 5, 6, 7, 8. It is not a coincidence that 2 times 4 is 8. So it is perfectly acceptable for you to jump right to the answer and skip these two middle steps. This was just so I can show you why this works, but your final answer would just be x to the power of 2 times 4, which is x to the power of 8. Let's make it a little bit more complicated. Now we've got two variables working together and they're being divided. So we can't do anything between the base x and the base y. They don't combine with each other. They're not like terms. Nothing happens in the numerator, just like nothing happens in the denominator. But between the x in the numerator and the x in the denominator, and the y in the numerator and the y in the denominator, we actually have two separate operations. So we just do each exponent individually. So what we actually have is x to the power of 2 divided by x, and when there's no exponent written, there's a 1 there. Not a 0, a 1. A base to the power of 0 just makes the value 1, the final answer, whole number 1. When there's no exponent written, when it's x to the power of what seems to be nothing, it's actually the power of 1. And this is separate from y to the power of 5 over y to the power of 3. And so now we just apply the division rule twice, once for the x's and once for the y's. So this is actually the same thing as x to the power of 2 minus 1 times y to the power of 5 minus 3. Figure out what 2 minus 1 is. That's 1. X to the power of 1 times 5 minus 3 is y to the power of 2. Putting these together, you don't need the dot. The dot's just to remind us that multiplication is happening. When it's different bases, we can just mush them together. And when it's to the power of 1, we don't need to write it. So our final answer is x, y squared. Not too bad, right? Here's one where a lot of people make mistakes. We have to remember that 2 gets raised to the power of 4. Now this is not 2 times 4, this is 2 to the power of 4. When there's only multiplication happening inside the bracket, it's as though the 4 gets applied to each thing. This is different than what you might have learned when you're expanding binomials. Remember those? For quadratics and stuff, that's when you're adding things inside the bracket and it's raised to a power. That's a slightly more complicated rule. For this one, we're just going to apply the power 4 to the 2 and the power 4 to the x. So we're going to have 2 to the power of 4 times x squared to the power of 4. 2 to the power of 4 is 2 times 2 times 2 times 2. Use your calculator and you will find that that is 16. And for this one, we apply the power to the power rule. So we have x squared to the power 4, and if you remember from part A, we already know that that's x to the power of 8. So it sort of adds a little curveball to our steps, where we have to work out what's happening with the whole number and what's happening with the power to a power separately. Part D, not super difficult. I mean, it's our best bet for this one is to actually work out what's happening in the denominator, make it one exponent only, and then do the full division. The same thing would be said if more stuff was happening in the numerator. We would simplify everything that we can in the numerator, everything that we can in the denominator, till we're left with as little as possible, then we do the division, which, if you remember, when the bases are the same, it's subtraction. So, the numerator is s to the power of 2. I know it looks like a 5, but it's an s. In the denominator, we have s to the power of 1, because there was nothing there, times s to the power of 5. So we add those exponents. 1 times 1 plus 5 is 6. Now, that was applying the exponent law of multiplication. We can apply the exponent law for division, which means we are going to subtract s to the power of 2 minus 6, which is s to the power of negative 4. Now, we don't just leave it with a negative exponent. Remember what a negative exponent means. It's right on the web page. It says it in red. Here it is, very, very bottom. Important, a negative exponent does not mean a negative number. A negative exponent is a reciprocal, which is a fancy way of saying that it is a fraction, actually a flipped over fraction. So reciprocal just means flip over the fraction in the base. If there's no denominator, this is still a fraction. It's a fraction over 1. So we're going to flip over s over 1 to get 1 over s to the power of 4. Notice when we took it and turned it into a reciprocal, the exponent went from being minus to a plus. For part E, we are going to be subtracting still because it's m and m, so we just leave the base alone, m, and we're going to subtract the exponents. Now we have to be very careful with this negative in the denominator. We have to subtract the negative 3. If you remember from your adding and subtracting integers laws, minus minus makes a plus. So this is m to the power of 2 plus 3, which is m to the power of 5. Finally, the scariest looking one, which was part F, which had a lot of stuff going on, and I'm just going to quickly write it down while we read it out to you, which is 8 multiplied by a to the power of 4 times b squared times c, all over 4 times a times b to the power of 3 times c. And there it is. So for this one, it's much like what I said to do for part B, where we do the x's and the y's separately. For this one, it's very similar, where we just work out what happens between 8 divided by 4 and the a to the 4 divided by a, which is a to the power of 1. Let's write that in. B squared divided by b to the power of 3, and c divided by c. And those are actually both 1s. C to the power of 1, c to the power of 1. So let's work them out one step at a time. This is going to be 8 divided by 4 to get started, which is 2. Then we have a to the 4 divided by a to the 1, so we subtract 4 minus 1 is 3, and so we rewrite a with an exponent of 3. Then we have b to the power of 2 divided by b to the power of 3, which is b to the power of 2 minus 3, which is negative 1. It's really important to remember the order of the subtraction matters a lot, because if we did 3 minus 2 and got positive 1, this answer would not be correct. Finally, we have c to the power 1 divided by c to the power 1. Anything divided by itself is 1. So we could just say this is all times 1, which doesn't change the answer. Or we can apply the division rule, which means we're going to do c to the power of 1 minus 1, which is 0. And this reinforces what I was saying before, where anything to the power of 0 is just 1. So it doesn't actually change anything. So anything multiplied by 1 is whatever it already was. So this is like saying 2 times a cubed times b to the negative 1 times just 1. So we don't even have to write this down. This is equal to 1. And so multiplying by 1 doesn't do anything. So in our next step, I'm going to rewrite this without the c to the power of 0. And we're not quite done. We just have one last step where we have to apply the reciprocal rule for this negative exponent. So we're going to have 2 times a to the power 3 times 1 over b. And that will actually result in 2 times a to the power 3 all over b, When it's all being multiplied by this, anything with a negative exponent in the numerator can just be shifted down into the denominator like this. And remember, when we don't write the exponent, it means it's to the power of 1. Okay, I hope this is enlightening for you and that it helped. Since this video is already 10 minutes, I'm going to leave the questions for part 2 for you to try on your own. Please send me an email if you have more trouble with this, and I will be happy to go over more of them. Have a great day.